We're going to be looking at the types of chemical reactions. We have 5 different types. And the first one that we're going to look at, it's called single displacement, or sometimes it's just called displacement. And make sure that you're filling out your chart as you are watching these videos. So the single displacement is called displacement on your chart. So either one works. They both represent the same type of reaction. And so what happens in this reaction is that an element that's higher on the activity series, so you'll have an activity series to use to determine if this reaction will occur. And that element will replace the element with the same oxidation charge, leaving that original element alone. So let's look at the general formula for this. So I have element A, and then I have compound BC. So this is what you're going to see for a single displacement reaction, an element and a compound. And then we're going to produce in the products a compound and an element as well. And so A is going to be replacing B. And then we have to make sure that A is higher in that activity series. And so just check out the activity series, make sure it's more reactive, and then you're good to go. So then the reaction will occur. So A is higher in the reactivity series, so then it can replace B, and now B will be left by itself. Also, A and B have the same oxidation charge. So these are going to both be cations because of where the B is written. A could also replace C if C was an anion and A was an anion. So you have to just really look at those oxidation numbers and make sure that positive replaces positive, anion, and negative replaces negative. So in our examples, we have iron, which is a cation, and then we have lead nitrate, so an element and a compound. So the iron is higher on that activity series, so it can replace the lead and kick out the lead. And now the iron is with the nitrate, and the lead is left by itself. So when you're doing a single displacement reaction, the element always replaces the one with the same charge as this. So iron, we know, is a cation, so it's going to replace lead, which is a cation. Nitrate is an anion, so it's going to want to combine with the anion because opposites attract. Then when we look at chlorine, we have chlorine and sodium iodide. So this is also a single displacement reaction because you have an element and a compound. And so the chlorine is an anion, so it's going to replace the anion in the compound. And so iodine is the anion in the compound. And so therefore we're going to form sodium chloride, and then we are going to form iodide, which is just by itself. And iodine and chlorine are both diatomic, so that's why they have the little 2's after them, because they're by themselves. So whenever elements that are diatomic, those H7s are by themselves, you must have the 2 there. Right here, it doesn't have to have the 2 because it's with sodium, it's not by itself. Same thing with chlorine. It doesn't have to have the 2 because it's with the sodium. So, but if it is by itself, then it has to be identified as diatomic. Then we have another one. We have potassium and aluminum chloride. So potassium forms a cation and aluminum is the cation. So therefore, that's the one it's going to replace. Potassium is higher on the activity series, just like the chlorine was, just like the iron was. And so it can replace the aluminum, and it's going to form potassium chloride and aluminum. So now the aluminum is by itself. So in a single displacement reaction, we see the element and the compound, and then we form a compound and element in the product. So another type of chemical reaction is called the double displacement reaction, in which you have 2 soluble compounds. And what they're going to do is they're going to switch partners and form in the product 1 soluble compound and 1 insoluble compound. So typically we'll see a solid as well. So looking at a basic general formula for this, element A or compound AB and compound CD are in our reactants, but then what happens is they switch. So now A goes with D and C goes with B. So when you're switching them around, it's always got to be opposites attracting. So A is a cation, B is an anion, and so the cation is going to want to go with the anion of the other one. Whenever we write chemical formulas, we always write the cation first and the anion second. So we have A and D going together because that would be a cation and an anion. and then C is the cation and B is the anion. So opposites always have to go together. So if we look at some examples of double displacement reactions, we have sodium hydroxide and calcium chloride. And sodium is the cation, hydroxide is the anion, calcium is the cation, chloride is the anion. And so when they switch, the cation of the one always goes with the anion of the other one. So sodium and chlorine go together, and then calcium and hydroxide go together. So then this would be a double displacement reaction. They switched how they were combined. Another example that we have, potassium sulfate and lead nitrate. So potassium is the cation, sulfate is the anion, lead is the cation, and nitrate is the anion. So the potassium and the nitrate are going to combine together, and the lead and the sulfate are going to combine together. And so we'd end up with potassium nitrate and some lead sulfate. Also, you'll notice that both of these are aqueous or soluble in the reactants. And then in the product, I have an aqueous and then a solid. And so that's what you must have in order to have a double displacement reaction. The same is true with the second example. This is aqueous reactant, and then we end with an aqueous and a solid product. Another type of chemical reaction is the combustion reaction. And in a combustion reaction, it's going to contain carbon, and carbon is going to burn. And of course, in order for this to happen, you have to have oxygen. And we're always going to form the same two products, carbon dioxide and water. This is also an exothermic reaction, which means energy is going to be given off. The general formula for this is some carbon-containing compound. So any of our hydrocarbons, whether it be an alkane, alkene, or alkyne, and we're going to combine that with oxygen, and then we always get CO2, H2O. And then, like we said, this is an exothermic reaction, so it's also giving off energy. So the combustion reactions are probably the easiest ones to identify, the easiest ones to write, because the only thing that's going to change is this carbon-containing compound. Otherwise, oxygen is always going to be another reactant. Carbon dioxide and water and energy are always going to be the products. So if we look at this example here, we have CH4, so that's methane plus oxygen gives us carbon dioxide, water, and energy. You'll notice that actually all of these are supposed to be listed as gases. All right, so make sure, because it's not liquid water, it's actually a gas of water that comes off for this particular reaction. Typically when we see water, we would write liquid, but in a combustion reaction, it's actually in vapor form. So that should be gas. So all of the compounds in a combustion reaction are gases. We always form carbon dioxide and water. The next type of chemical reaction that we have is a synthesis reaction. And in a synthesis reaction, two or more smaller elements or compounds, typically we see elements, but it can also be compounds, combine together to form one larger compound. So a key factor to a synthesis reaction is that there's only one product. So when we look at this, it's just element A plus element B gives us compound AB. Some examples of this would be magnesium and nitrogen combined together to form magnesium nitride. Iron and oxygen combined together to form iron, and this would be iron 2 oxide. So that's all there is to it. There's no specific rules or anything about it. Just the fact that you'll just be forming one product from two typically smaller elements that combine together in a synthesis reaction. Another type of chemical reaction is decomposition. And decomposition is basically one reactant, one larger compound breaking up into two or more smaller compounds or elements. So a key factor to a decomposition reaction is seeing only one reactant, and then it just breaks apart into its different components. So we have some phosphorus and oxygen combined together, and now you can see that they're separated. Here's phosphorus by itself and oxygen by itself. And remember, now that oxygen is by itself, it is a diatomic element. So that's why we have the little 2 right there. Then we have potassium chlorate, KClO3, and that breaks up into potassium chloride and the oxygen breaks up. So one reactant for each of these breaking up into its individual components for a decomposition reaction. So now that we've looked at all the different types of reactions, let's see how we do. So the first one says, in a single displacement reaction, sodium would replace. So remember, sodium, first of all, is a cation, so it can only replace a cation. And if we look, we have chlorine, which is an anion, oxygen is an anion, iodine is an anion. So magnesium is our only choice here because it's the only cation that we have. So yes, sodium should replace magnesium. And then just as another double check, sodium needs to be higher than magnesium on that activity series because this is a single displacement reaction. And in a single displacement reaction, you have to use the activity series. That's the only one you have to use it for. It doesn't matter in any of the other types of reactions. Just in the single displacement reaction, do you use that activity series. So if you want to make yourself a little note on your activity series that says use for single displacement reactions, or known as just displacement reactions, either way, it still represents the same type of reaction. But be sure to always use that activity series. Sodium, yes, is higher than magnesium, so it can replace the magnesium, and they are both cations. Then if we have potassium chloride and lithium bromide were to undergo a double displacement reaction, what would form? So we know that these are both compounds, and so we know that it's going to be a double displacement reaction because only in a double displacement reaction do we have two compounds as our reactants. So we're looking at potassium chloride is KCl, and lithium bromide is LiBr. So if they were going to switch, then the potassium would go with the bromide because this is the cation and that's the anion, and lithium would go with the chloride because this is the cation and that is the anion. So we should be forming potassium bromide and lithium chloride. However, in a double displacement reaction, you need to make sure that this reaction will actually occur. So if we look at the solubility rules, and this is the only one where you have to look at the solubility rules, is for double displacement. So looking at the solubility rules, potassium chloride is aqueous, lithium bromide is aqueous, so that's good. So you have to have two aqueous reactants, and then the products must be aqueous in a solid. So if we look at potassium bromide, that's going to be aqueous. Lithium chloride will also be aqueous. So this reaction would not occur because there's no solid that forms. Everything in here is aqueous. So although we would think it should be potassium bromide and lithium chloride, but it also has to follow those rules for double displacement, which say in the products you must form an aqueous and a solid, but they're both aqueous, so that doesn't work. Then what type of reaction would this represent? So we have AB and compound CD, and then we get AD and CB. So looking at what happened here, A went with D and C went with B. So this would be a double displacement reaction. This is the only type in which we have one compound, two compounds in our reactants, and then two compounds in our product. So this one would be the double displacement reaction. Then what are the products of every combustion reaction? So combustion reactions are super easy to predict because they follow that same pattern. It's always as a product forming water and carbon dioxide. Oxygen and organic compounds are alkanes. Alkenes are alkynes. These are the reactants. So organic compounds all contain that carbon. So that will change. So depending on if it's going to be methane or if it's going to be propane or if it's going to be heptane or whatever it's going to be, but it still contains carbon. And then oxygen will always be in the reactant as well. And then you have water and carbon dioxide as your products in every combustion reaction. Then we want to figure out what type of reaction this is. So this is magnesium and chlorine forming magnesium chloride. So we have two smaller elements and we only have one product. So that is going to be a synthesis reaction. So you really have to look at the elements that are involved and what they're doing to figure out what type of reaction you have.